Alright, now we're going to have a look at a tech active example. Still kinematics. So a particle moves in a straight line so that its displacement is x centimeters from the equilibrium point P at time t seconds. The equation relating x and t is x equals 2 sine of 4t. And the first question says, when does the particle first return to the equilibrium point P? Now, when we're talking about returning to a point, we're looking at displacement. So we're interested in the formula with the x equals 2 sine 4t. So let's type that into our calculators. Graph function, make sure you're in radian mode. And we're going to type 2 sine of 4x. And let's set a domain because we're just interested in when it first returns to the equilibrium point. So I'm going to start with a domain of, say, pi or 0 to pi and see whether that gives me enough information to be able to answer the question. And that looks okay. It comes back to our equilibrium point a couple of times. So every time it crosses the x-axis, we're at the equilibrium point. And what we're going to do is just find a few significant points so that we can draw a graph. So if we go G-solve and we say max, I can see that my amplitude is 2, and I know that from my equation. And again, G-solve my min. Okay, that's at -2. So I know that I'm oscillating between +2 and -2. I also want to know where it is crossing the x-axis, so I use my root, and I can see at 0.785, 1.57, and 2.35. Now, those numbers can just be used as that, but if you use these numbers a lot, you know that 0.785 is pi on 4 and your 1.57 is pi on 2. So I'm going to put in pi on 4, pi on 2, and 3 pi on 4, although you could use the decimal values for that. I'm going to put in 1 and 2, -1 and -2. Very importantly, I'm going to say from graphics calculator. Okay. And I'm going to, where was my max? If I go back to G-solve max, I see it's at about 0.392, which is around about, well, that's at pi on 8, isn't it? So we're going to have something happening there, something happening there. We know that a sine curve is a symmetrical function, so halfway between all of these values on the x-axis is where we're going to have our maxes and our mins. And we're going to sketch a nice clean curve, as symmetrical as you can through there. We know that that's time in seconds and that is in centimeters. Alright, and then in order to answer the question, we're going to say from our graph, our equilibrium is when x equals 0. Okay, and that's at t equals 0, pi on 4, pi on 2, etc., etc. And our first time, if we wanted the exact values, we would use our root and say it's at 0.79 seconds. So first time is when t equals pi on 4 seconds, and that's approximately equal to 0.785 seconds. Alright. Find the time at which the particle first reaches its maximum displacement. Okay, so again, our maximum displacement is going to be at positive or negative 2. And the first time will be when it reaches positive 2. So again, from our graph, x equals 2 when t equals, well, we know it's pi/8, which is approximately equal to 0.39 seconds. Okay, so we're always referring to the graph when we are using or making use of the graph. Okay, now it says find an expression for the velocity of the particle. Velocity is related to displacement in that it is the derivative of the displacement, and we always need to acknowledge that that's what we're doing. So we're going to say velocity is the derivative of our displacement, and we have a chain rule. So we have that V is equal to 2 cos of 4t multiplied by 4, and that's going to be 8 cos of 4t. Okay, then it says find the second time the particle comes to rest after t equals 0. So coming to rest means we are relating to the velocity function. Okay, so that means we want to graph the velocity function. So we're going to type in 8 cos of 4t, and again it's the second time, so I think we could probably go with the same domain. And I don't want to see the original function, so I'm just unselecting that. And there we go, we have our velocity function. Notice it's a cosine graph, which is what we expected. Our amplitude again is 2, and we can double check that by looking at what our maxes are. Oh, sorry, not 2, 8. And we can see our maximum is at 8. So I'm going to write in 4 and 8, and our minimum is going to be at negative 8. And our times when it crosses the x-axis are going to be at pi on 8. And our maxes and our mins are going to happen at our pi's on 4s and our pi on 2. Alright, so if we keep our same scaling, pi on 4, pi on 2, and pi on 4, we know that we're crossing our x-axis here, positive 8, negative 8, and we're just copying it from our calculator. Doesn't have to be absolutely perfect. As long as you've got your main parts and the labels. Oh, going back, what we need to do is label this point of 0.392 and 2. All right, make sure you label any points that you are referring to. So we want pi on 4 and 0.785. All right, so let's sketch this. Okay, and we've got time in seconds, and this is velocity in centimeters per second. Alright, and the second time the particle comes to rest, we're also going to say using the graphics calculator. And the second time is actually going to be this time over here. Okay, so particle is at rest, then v equals 0. And the second time from the graph, and we're going to look and see, oh, it's at 1.18 seconds. So t is approximately equal to 1.18 seconds. And again, we're going to label that point. So that would be 3 pi on 8, but we would have 1.18 and 0.